Now, here's my three equations. Y equals 2x, y equals x squared, and y equals 2 to the x. Those are my three, right? Those are my three. Do you know how to graph y equals 2 to the x? Some of you are going to say yes. Others of you are going to say I'm not 100% sure. So here's what you're going to do. If you're not sure how to graph that, you're going to open into Desmos. Does everybody have Desmos open? Yeah? You are going to type in y equals 2x. So do exactly as I do, please. Y equals 2x. Then you're going to come hit the table. And you're going to put our table values in. So -3, -2, -1, 0, 1, 2, 3. I got those right off my paper. Now the problem is this is starting to not work, right? So what you're going to do is, let's hope this works. This didn't work. Oh, this is not working. Okay, that's okay. We'll get it to work. It's not working today. Y equals 2x. No, we're going to do it the way I want to do it. Y equals 2x. If I want where x equals 3, I divide by x equals -3, right? We've done this before. Yes? I zoom out. My point is where? -3, -6, right? So I come to my graph. I go -3, -6. 6. Now I can do that the whole way across. I could do -2, -1, 0, 1, and 2, right? William, can you please use the pencil? It's going to bleed through if you use that. Do you understand? Thank you. Now, I want you from this point to go up 2 boxes into the right one. So up 2 to the right one. So from this point we graph -3, 6. Go up 2 boxes to the right one. I want you to do it again. Up 2 boxes to the right one. Why am I going up 2 and over 1? What? I am going to make a line, but why did I pick 2? It's what? Oh, it's not what x is.
Y.
It's not what y is. Look at your equation. Where did I get to 2 from? Y equals 2x. Does anybody remember what that x is? If it's in front or the 2 ways, it's called your, starts with an S. Slope. It's your slope. Remember, we can get our slope. So from each point, you're going to go up 2 over 1, up 2 over 1, up 2 over 1. And what are you going to do with those? You're going to draw a nice little line. And that's linear. That's linear. Does everybody have that? Does everybody have that? Okay. Go back to Desmos. We're going to change this one. What's my next equation say? It says what? Y equals x squared, right? How do I do y equals x squared in Desmos? I do an x, and then how do I get this squared?
You have to
shift 6 squared. Y equals x squared. Have we seen this kind of graph before? Does anybody know what it's called?
It's called
a parabola. Not a parabola. Not anything weird like that. Don't call it a parabola. It's a parabola. Now, graph this point, 0, 0. Graph it on your paper. 0, 0. I graphed it. I need to graph at least one more point. You actually have to graph 2 more points. So, x equals gosh. -1. Intersects here, yes? Graph that point. -1, 1. And then do x equals 1, which is also 1, 1. So you're graphing 1, 1, -1, 1. And you're going to make a U. Make sure it looks like a U and not a V. If it looks like a V, that's a completely different function. All right, completely different function. Last one. Y equals 2 to the x. So go into Desmos and graph y equals 2 to the x. Y equals 2 to the x. Put that one in Desmos. Does that look like a shape we dealt with yesterday? It better. Y equals 2 to the x. Now I have a question for you. Is this growth or is this decay? It's growth. It's getting bigger. It's doing that J shape. Now, Desmos gives us that point. You graph it. 0, 1. 0, 1. I want you guys to notice something. Does this graph ever go down into this region?
No.
No. There's a reason for that. The reason is it has what we call an asymptote. But asymptotes are not a standard for which you guys have to learn and know. But you have to understand that if you draw it underneath there, it's not technically right. So you guys are going to see kind of where the graph kind of stops and stays on a line, and that's important. So am I going to go below 0? No. But I need another point. So we said this was growth, right? Yes, no, maybe. This is growth. So if this is growth, we're going to do x equals 1 in Desmos. We're going to do x equals 1 in Desmos. When you do x equals 1 in Desmos, do they intersect? They do. You click that point. It's 1, 2. So now there's my 2 points. Now when I go to graph this, you skim the line, connect your 2 points, and go straight up. So then can you just tell me that next time?
Yes.
Thanks. All right. Cool? Now, here we go. This is your general formula for an exponential function. Y equals a times b to the x. So if you ever see your exponent, if you ever see the x and the exponent, then that note, it has to be exponential. It has to be exponential. Now, there's 2 variables that we're going to replace in here. We're going to replace a and we're going to replace b. Now, a. I want you to write this down. A are 2 kind of things. It's your y-intercept. A is my y-intercept. A is my y-intercept. You also hear something else. This is also called my initial or starting value. Okay? Those are the three things you might hear when it comes to that A value. Y-intercept, initial value, starting value. Your B. Is your growth or decay factor. I don't want you to write the rate because that's different. It's your growth or decay factor. And it's the factor because you're multiplying. You need to take these notes because this is not correct. You need to stay awake. It's your growth or decay factor because you're multiplying. Now, I have steps for which we're going to use to graph these. Step 1, what does it say to do? Put it in Desmos. Step 2, what does it say to do?
Or
What's it say on the paper?
Is decide whether the graph is growth or decay.
Growth.
Desmos said.
Right? Growth. Growth is what letter?
J.
J. Decay is
L.
L. And then you're going to plot the y-intercept, and then you're going to use 2 points. Yes? Here we go. We're on to the back of the paper. Now, some of you may start figuring out whether it's growth or decay before you put it in Desmos. Awesome. We'll talk about that next week. I'm not stressed about that. Let's put the first one into Desmos. 3 parentheses 4 to the x. There it is. Is everybody's match mine? Growth or decay? Growth. So on your paper, make sure you're circling that it's growth because that's important. Yeah? Okay. Now, when I go back to Desmos, is this my y-intercept? That is. So you're going to graph it at 0, 3. And I also want you to write it down on your paper. So your paper should have the y-intercept of 0, 3. A y-intercept needs to be an entire coordinate. I am extremely picky about this. If you put 3 down on your quiz on Friday, the graded assignments, unless you use your notes. If you just put 3 down, I will not give you full credit for it. I'm really picky about certain things, and I don't know why I am. I just am. It's just the way it is. Probably came kind of like you. I'm picky about certain things because it got hammered. Okay, 0, 3. Now, do we say this is growth or decay? I already forgot. Growth. So flip back on the front side of your paper. If it's growth, what does it tell you to type into Desmos?
J or L.
No. We know it's growth. We know it's at J. What does it say underneath that?
If you're using X equals 1.
I use X equals 1 if it's growth, right? So I put that into Desmos. So I type in X equals 1. And do they intersect? They do. Where do they intersect at? 112. But what's the problem?
That's outside.
It's offside. It's outside of the graph, but can we kind of estimate it? Can we estimate it? So 112 is about right there. Yeah? Give or take. I might be off a little bit, but that's okay. Now I have one more question for you. Is my graph ever going to come below here? No. So when I graph it, please look at me. Am I going to graph it like this? No. Am I going to graph it like this? I'm going to graph that second one. I don't want to go below that line. It's what's called an asymptote, which is an invisible line like that. Now, I put arrows on it, yes? Can I tell you that the domain is the easiest thing? Do we remember domain and range from a couple weeks ago? Domain, I come from the left. If I come from the left, do I hit a point or an arrow? Arrow. If you hit an arrow from the left, that means, which one? Negative infinity. Now when I come from the right, do I hit a point or an arrow? Arrow, which is, that is your domain for every single exponential function. So guess what I want you to do right now on the back of this paper? How many other domains are on the back of the paper? There's 3, right? Do you know the answer for every single one of those? Write it down. Yeah, it's the same for every single exponential. Wherever it says domain, you need to now write negative infinity to positive infinity. So here, down on C and down on D. Negative infinity to positive infinity. Write it quickly, please. We're not going to do B because we just did B on the front. We can cross off B. We're not going to do B. We did on the front. All right, we ready? C, I want to graph it. What's the first thing I'm going to do, ladies and gentlemen? Talk to me. Put it into Desmos. Okay, let's talk about this. Once you put it in Desmos, make sure yours matches mine. Is it growth or decay?
Decay.
It's decay. Does everybody agree it's decay? It's that L shape. So what should we do on our note paper? Circle what?
Decay.
Circle decay. Boom. Okay, I need that y-intercept. Does Desmos always give me my y-intercept? It does. So I click on it. Do I write exactly what Desmos says? You write exactly what Desmos says. So 0, 3. And I would go ahead and start graphing that. We know our domain. Sorry that this thing is so stupid. Now, growth or decay? Decay. So I do x equals 1 or x equals negative 1? Negative 1. I look where they what? Intersect, which is at negative 1, 6. Am I going to go below 0 on this one? No. So your graph should look like that. I would like you to try letter D for me, please. Try letter D for me, please. Plug that into Desmos, kiddos. Growth or decay. Absolutely nothing. Oh, do this one for me, sweetheart. Do that one for me, please. Yeah, they're right there, sweetheart. Just 38%. That's all you need. You got it. I know, I'm not, no pressure, but yeah. Oh, put this in. Y equals 4 times 0.25, say yes. As you guys do math, see what they intersect. Yep, you're okay. You just gotta do math. It's okay. Does this one fit on the graph? No, but can we estimate it? Can I go below 0? No. Can we graph exponential functions? Yeah? Okay.